Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 87 of physics, and today's lecture we are going to do a work example which is labeled as 14.1. Let us first understand the question and then we will retaliate accordingly. uh, Question is saying, given that the speed of light in vacuum is 3.0 into 10 raised to the power 8 meter per second. So let us write the data. C is equal to 3.0 into 10 raised to the power 8 meter per second. That is the first piece of information. Then they are saying calculate the speed. So we have to calculate the speed of the light in crown glass of refractive index. Refractive index is always denoted by n, and that is given to be 1.52. Remember that refractive index doesn't have any unit. It is a unitless quantity. So these are the data. Now we yesterday in the last lecture derived that uh, n is equal to c divided by v, where n is the refractive index, c is the speed of light in vacuum, velocity of light, and the speed of light in vacuum, and speed of light in crown glass we have to uh, find. So speed of light in vacuum is 3.9. Simply we have to put the values, and I have to write 1.52. C is 3.8 into 10 raised to the power 8, and then we have to write V, which we are going to find. So we can write this equation as 3.8 into 10 raised to the power 8 and 1.52, and that will be equal to meter per second. Similarly, we can write that is 3.8 divided by 1.52 into 10 raised to the power 8 meter per second. Similarly, when we calculate these things, we will get 1.97 into 10 raised to the power 8 meter per second, and that is the ultimate answer with us. Now let us turn our focus to question example 14.2. They given us a figure. I made the completed form of this figure. Let us understand. Figure shows a ray of light incident on the surface of water at an angle of incident. So here I am writing angle of incident is equal to 60 degree. The refractive index of glass, and that is n, is equal to 1.33, and that is a unitless quantity. In the A part, they are saying calculate angle of refraction. So we know that sine angle I divided by sine angle R is equal to N. Dear learners, let me clear one thing. This formula is used only in the case when the light rays are entering from less denser medium to the denser medium, in this case glass. But if a light ray is entering from denser medium, in this case the glass, to a rare medium, in this case is air, in this case there is a water and air, so then we will use this formula, sine I divide by sine R is equal to 1 over N. Keep these things in mind. There's whatever the scenario is, accordingly you have to use the formulae. So because in this particular scenario the light ray is entering from the air to the water, then we are using this formula. The data is given to us. Let me first insert the data. So I am writing sine 60 degree divide by sine R, because we are going to find this sine R. So we are writing 1.33. Now simply we can write this as sine R, and then I have to write sine 60 degree, and when this is coming, so I will write 1.33, because I am shifting this on the place of this, and this 1.33 will come on the place of sine R, and then I arranged it. So here I can write this R is equal to sine inverse, and then we have to find sine 60 degree, 1.33, and when we calculate it we will get 40.6 degree. So in this case R is equal to 40.6 degree. Okay, there are two formulae. One is this one and one is this one. So when speed of light in vacuum, speed of light in a particular media is given, then you have to use the first one. And if incident and refracted rays along with refractive index is given, then you have to use this formula. Ladies and gentlemen, now let us think about the reverse process. And the reverse process is saying that can we get again 60 degree if we are reversing the situation. But before that, this is the complete diagram in which we got this 40.6. That was the part 2, that draw the complete diagram. Now we have seen so far that when light enters a denser medium at an angle, the light ray will bend towards the normal as seen in this figure, this one. uh, of the work example. What would happen to a light ray that is emerging from a denser medium into a less dense medium? For example, from the figure, if we reverse the direction of travel of the light ray, that is, the light ray now travel from water into air. The angle at which the light ray is incident upon air-water boundary is now 40.6 degree. Remember that now this 40.6 is the incident ray, and we have to find this angle in this case, and I told you that you have to use this formula when you are having a situation in which the light ray is emerging out from the denser medium to the less denser medium, in this case air. So then you have to use this formula. So let us use this formula, and I am writing sine 40.6 degree divided by sine r is equal to 1 divided by 1.33, 1.33, and when we calculate this, the whole scenario, then we will get 60 degree. So it means that the reverse is also possible. You calculate these things with the calculator, and then you will get 60 degree, as it is already here 60 degree. So remember these two formulae and understand the situations in which you will use it. Now there is a calculation of this one here. So let me write in this case from cross multiplication that sine r will be equal to sine 40.6 degree multiplied by 1.33. Now when sine is going to the other side of this equation, then it will become sine inverse, and there is an option available inside the calculator that when you press the shift key on the top left corner of the calculators and then press the sign, so it will give you a sign like this, sine inverse, and then you have to write this bracket, and after the bracket you have to write these things and then close the bracket, and when you press the equal symbol you will get 60 degree. It will be 60.000 like this. So you will confirm that this will be the answer. Now there is a challenge question given, and challenge questions are always challenging. Let us understand this. I solved it for you people in advance because there were calculation involved in it. So I did it, and let me explain it step by step. A ray of light is incident on a rectangular glass block of refractive index 1.5. So I wrote this here, n is equal to 1.5. If the ray strikes the surface PQ, which is given here, PQ. So if this is striking PQ at an angle of incidence 60 degree, it is also shown here that angle of incidence is 60 degree as shown in the figure. Calculate number A part. I is given as 60 and we have to find in the A part the angle of refraction or at the air to glass boundary. Now first they have written air and then glass, so it means the ray is entering from air to the glass as shown in the figure. So here in this case you have to use this formula, putting the data sine 60 degree divided by sine r is equal to 1.5 and then rearranging it and finding this value, you will get 36.27 degree. But that is not the ultimate answer, because we found this angle and actually we have to subtract this from this angle, so we will find this angle. This is the angle of refraction, not this one. So we found that angle and here we have to subtract because this total is 90 degree. So here if you can see in this particular case we are subtracting it from 90 degree and that will be equal to 57.73 and that is the answer. Now in the second part they are saying here that the angle of incident x in the angle glass. Now we have to find this one because this line and this line, they are parallel to each other because both of them are the normals of this glass air junction. So this is a transversal line. So according to the alternate angle theorem, this angle will be equal to this angle. So this angle is, we found that 36.27 degree. So this will also be 36.26 degree and I wrote it here that x is equal to 36.27 degree and that is due to the alternate theorem. Dear learner, if you are not understanding this, so see my mathematics course and most probably that will be the lecture in between 75 and 80 and above them. So go and visit my channel and there in mathematics course you can study it in greater detail, that what is alternate angle. So that was the B part. Now we are turning our focus to C part, the angle of glass to air. Now here it is given first the glass and then air. So the situations are now reversed. First it was air to glass in this case, but here from the denser medium it is going to the rare medium. So we have to use this formula and I told you that you have to use this formula. Simply insert the value of I because it is now incident and this is the refracted with the normal. So 1 over n sine 36.27 and sine r is equal to 1 divided by 1.5. Sine r is equal to this, and when you will get the original angle, that is 60 degree. So I also got this 60 degree here as well. So that was the challenging question, and yes, it was a challenging in the sense that people are saying that we found this angle, so this is 36 and this is the, but this is not the answer. You have to subtract it from the 90 degree, then you will get this angle. So now we are coming towards some daily phenomena of refractions. It means that where we can use this refraction phenomena in our daily life. The first phenomena is swimming pool appears shallower than it really is. Then it really is. What does it mean? If you are seeing the swimming pool from the above, you will say that it is shallower, not deep. This dash line in the figure is showing what you are seeing, and this bottom line is showing what actually is. So when the light is going from this, so you know that it will move away from the uh, normal, and in this case one line will go in this way. So if I show you the figure clearly, then you will see it here. This dash line is showing. So that is why don't believe that when you are seeing in the swimming pool, the bottom of the swimming pool, it will not be looking real to your eyes. You will be deceived. And if you jump into the water, then nobody will stop you from yelling, help me, because the water is deep for me. So this is one thing you have to keep in mind, and all these things are happening due to the refraction phenomena. Similarly, we are having multiple images formed by a thick glass mirror. Dear learner, if there is a thick glass and you want to see this object, then there will be multiple images of this you will see due to refraction. The first one is this, the second one is this, the third one is this, and this is image number 4. Dear learner, I saw many questions like this in the CIE O-level exams. They given us such type of figure, and they are asking that which image will be the sharpest one and what will be the faintest one. So let us understand. The first one is this line is coming and it is bending, and then they are going from here, and that is the actual phenomena occurring from this object. So when you are seeing this image, you will see it here, and that will be the sharpest one. This will be fainter one because this is not the actual phenomena at the surface. You are seeing it, so it will be the faint one. And then you are for multiple reflection, another reflection, you will see it here to the eyes. This will be the fainter one, and with another reflection here, and you will see it at the fourth. So that will be the faintest one. That will be the faintest. The further away image after seeing from the thick glass mirror, you will see that the fantasy students are always confusing that the nearer image will be the sharpest one, but it is not the case. I have to show you this in the form of a table, and that table is given to you. I1 is the faint image, image 2 is the very bright image, and the fainter image is I3, and I4 is the faintest image. That is given in the form of a table as well. So the third one here is bent object in liquid. Whenever you are seeing a straw inside the glass of juice or water or in a liquid which is a bit transparent one, you will see that the straw is broken, bent down, and you will be deceived. How? That is, this is the image from the bottom of this I am drawing, because light is moving from the bottom of this object and it will bend away from the normal in this case. So you will see that the straight line will see this position. This will be the position of that straw, not the original one. Your eye will see this position inside the water. Outside the water, it is correct. But when it comes to the inside of the water, then it is like this. So, this is another thing, and let me tell you that if somebody is telling you that if I am putting a coin in this location at the bottom of the glass, very important question, I need your attention, and your eye is here, this glass is not allowing you to see this. Can you see it from this position? Pour water inside this, and then it will be looking here to you, and then your eye will see it. So yes, this is another consequence of that refraction. There are other daily uh, consequences of this. Refraction also contributes to the formation of rainbow. Yes, after the rain, we are seeing 7 color like this of different. After the rain, there are droplets of water, and they are playing the role of a prism. When white light is coming, it is spreading and diffracting it into these 7 colors, which are called the colors of the rainbow. Not only reflection, refraction phenomena is taking place. Total internal reflection, which is our next topic, along with the dispersion of white light into several colors. So this phenomena is taking place. In the case of, this was the first, and the second case was mirages. You have to understand that mirages are formed when in the hot summer afternoon you are driving on the road so far away. The road is looking like that there is a water surface on the road, and the trees near to it can also be seen inside that water. So that is called the mirages, and that is also due to the reflection. So in the case of mirages such as pools of water on the road on a hot day, they are formed by combination of refraction and total internal reflection. So there are two phenomena involved inside it, and those are the total internal reflection. That is our new topic. In the next topic, we will discuss that. For the time being, thank you very much for your time. Allah Hafiz.